Okay, I'm going to start here with a couple of quick questions. We have a rotating strap that completes 180 degrees in 20 seconds. So the question is, how fast is it moving on the average? And it completes a subsequent 180 degree rotation in 30 seconds. That is, it does a total of 360 here. 180 degrees in the first 20 seconds, how fast is it moving during that 20 seconds on the average. And then the next is in 30 seconds. And not asking for an average, for an answer to how fast on the average, but what's the best estimate of acceleration? So think about those. You should pause and think through these questions. Some answers can be gotten in your head. And in just a minute, I'm going to answer this question, then give you another pause to answer this question. Start with a simple question. Rotating strap rotates through 180 degrees in 20 seconds. How fast is it rotating on the average? Now you can pause. You should answer that question before you watch me answer it. But anyhow, we're going to say that, this is like an average speed equals what? Pretty obvious answer is 180 degrees over 20 seconds equals 9 degrees per second. Now, that's not an average speed of the kind we've done most of our calculations with up to this point. Most of our calculations would be, and it goes a certain number of centimeters in a certain time, or a certain number of meters, a certain distance in time. Rotating object doesn't really go anywhere. It rotates, but you have motion, and you want to be able to talk about that rotational motion in the same terms we've used to talk about other types of motion. So we're going to qualify this. I'm going to call this average angular speed, okay, which is 180. Okay, well, the calculation is what it is. So we got an average angular speed of 9 degrees per second, and we don't want to use v for that. V would normally refer to speed, v with an arrow over it to a velocity. I'm going to call this omega bar. And please, please, please don't ever call this W, and don't ever use W on a keyboard to refer to an angular speed or an angular quantity, an angular velocity. Okay? It's omega. It's spelled O-M-E-G-A. Not W. Okay. Okay, so we have this average angular speed. Now, second question, what if this thing continues rotating through another okay, let's say continues, and in its continuity it's rotating another 180 degrees in 30 seconds. Okay? Answer the same question. Pause, get your answer. Well, the obvious answer is, in this case, your average angular speed is 180 degrees over 30 seconds, or 6 degrees per second. Well, now we have two phases of motion, and we better put some subscripts in this. We'll call this omega 1 bar, and we'll call this one omega 2 bar. Then my next question is, your best estimate of acceleration. So using common sense with the information we have, what's your best estimate of the acceleration involved in this situation? You should pause, do this. Okay, well, an acceleration involves a change in velocity and a change in clock time. Change in velocity, well, we can easily get a change in velocity here. Okay, so we could say or the change in speed, which we hope is a change in velocity, is omega 2 bar minus omega 1 bar equals what? -3 degrees per second. Now that I got negatives in here, you could say, well, we should be talking about velocities and displacements and stuff. And you're absolutely right. We're just trying to get our feet wet here. We'll formalize this in a minute. Okay, but anyhow, we have a change in speed. Try to get an acceleration. Now, you might have already answered this question for yourself, but what would we use for the change in clock time? So pause, answer this one. Okay? I would say that your change in clock time would be best measured from the midpoint of this 180 degree or this 20-second interval to the midpoint of this 30-second interval. So my suggestion would be measure from the middle of the 20-second interval to the middle of the 30-second interval. Okay? And how much time elapses from the middle of the 20-second interval to the middle of the 30-second interval? Well, 20-second interval lasts 20 seconds, so from the middle of that interval to the start of this 30-second interval is 10 seconds. And then another 15 seconds to the middle of the 30-second interval. Would be 25 seconds. So your average acceleration, but I'm going to put angular acceleration is what? -3 degrees per second divided by 25 seconds, which equals -0.12 degrees per second squared. And we don't use A for angular acceleration. We're going to use the Greek letter alpha. Alpha, not omega. Not A. Very bad form to call this W, and very bad form to call this A. Okay, so these are the ideas. Among other things, what you need to carry away from this, these calculations are very simple. You need to carry away from this, of course, that we're using the definition of rate of change, our original definition of average rate of change, to define these quantities. And we have a different notation to distinguish this situation, a rotational situation, from a straight line or motion in a plane or in space.